All right, let's solve some harder trigonometric equations. In this case, -7 is equal to -5 minus 4 cosine of theta plus 90. So it's a little bit more complex than the basic ones that we had before. But we already have a method for dealing with equations with more complexity in them, and that is the isolate, resolve, and solve method that we've used before. And that's exactly what we're going to do here. In this case, the trigonometric functions, so sine and cosine, tangent, secant, cosecant, cotangent, if we were adding those, would be the part that we need to isolate. So for this problem, we are going to start out by trying to isolate on one side of the equation this piece right there, that cosine of theta plus 90. So we're going to get that by itself using opposite operations. I have this subtracted 5 and this multiplied -4. So I'm going to add 5 to both sides first. We'll do this step by step so that we get -2 is equal to -4 cosine of theta plus 90. Okay. And then we'll get rid of the -4 by division. So I'm going to divide now both sides by -4. Canceling here. Okay. Well, not canceling on that second side, but reducing on this side. -2 divided by -4 will give me -1/2. So that now my left-hand side is -1/2 is equal to the cosine of theta plus 90. And we're like, it wants us to find all solutions in degrees, and that's where that 90 degrees comes from. But so my calculator should be in degree mode. But -1/2 equals cosine theta plus 90. At this point, we have isolated the trigonometric part. So our first step with the IRS method is to isolate the function. That's what we've done. Cosine is our function. We've isolated it on one side of the equation. The next part, the R, is resolve. Again, we're working with I, R, S. At this point, we've isolated. Now we want to resolve. That means get rid of the function. And this is accomplished by the inverse. We're going to take the inverse of cosine, which is the arc cosine or the inverse cosine of both sides. So that's what we're going to do now. Inverse cosine both sides. So we're going to do inverse cosine of -1/2 is equal to, and when I take the inverse cosine on this side, it's going to cancel. Now that looks very complex, so we're just going to remember that we are taking the inverse cosine of both sides, and that when I get to the right-hand side of this equation, it will cancel this cosine, which leaves theta plus 90 degrees. Now, in this case, -1/2 is from the unit circle, but again, I'm going to draw it out so that I understand what this situation is telling me. But we have resolved the function using its inverse. And now we would do the S, which is solve whatever's left over. In this case, inverse cosine of -1/2, which I can evaluate from the unit circle, is equal to theta plus 90. So we're going to evaluate this. We're going to go green. If the inverse cosine of -1/2, the inverse cosine of -1/2 tells me the angle where the horizontal leg of the triangle is -1/2. So if we were looking at that, here's my unit circle. put cosine negative 1, inverse cosine of negative 1/2. So that's what we're going to plot on this. Tells me that the horizontal leg of the triangle needs to be negative 1/2. So from the center of my unit circle, I'm going to go left half a unit. And since the radius of that unit circle is 1, that means I'm going to go about half the distance of that radius. And then like I did on the other equations, dotted line perpendicular to that axis. So far it looks like this. Now, my angles, oops, we don't want that one, are the angles that would connect there. So there's one solution. There's my other solution. And I can see that my solutions for this equation are going to be in the second quadrant and the third quadrant. And then I can either do it on my calculator, so just inverse cosine negative 1/2 or inverse cosine negative 0.5. Or I could remember from the unit circle that angles that have a cosine of 1/2 are 60-degree angles. And in the second quadrant, that's 120 degrees. And in the third quadrant, that's 240 degrees. So those are my solutions. That's the evaluation of inverse cosine negative 1/2. So that's what I'm going to write. We now have the inverse cosine of negative 1/2 is either 120 degrees or 240 degrees. And remember, the cosine, the sine, they all have this period. They repeat themselves over and over and over again. So we add that period to our solutions, that plus or minus 360 degrees. So plus or minus 360. I think Khan Academy uses in as their counter, so we're going to use in here as well. 360 in is equal to theta plus 90 degrees. Theta plus 90 degrees. Okay. Now, a little better since it's all numbers now. We don't have the function there anymore to get in our way. A little worse because you got this jumbled bunch of numbers. It's very hard to keep track of that complexity. So, again, I don't really need to. Look at this. All I have to do is solve for theta. No matter how complex the other side gets, if I look at this, I can tell that all I really have to do to solve for theta, to get theta completely by itself, is subtract 90 on both sides. Now, subtracting 90 degrees is not going to change the period. So that 360 is going to fall. The only thing that changes the period is multiplication or division, which we'll see in just a second. So all I have to do is subtract 90 from those two angles. So I do 120 minus 90 is 30 degrees. 240 minus 90 is 150 degrees. Plus or minus the period, 360 in times, is equal to theta. Okay. Now we took that one fairly slow, step by step. We isolated the function. I got rid of the function. I resolved it by using the inverse function. And then I solved whatever was left over, which will be whatever was inside the function at the beginning, which was this plus 90 degrees by subtracting 90. The hard part is remembering that unit circle, or for a lot of stuff, using the calculator and finding those values. Do one more. going to scroll down to same idea. Find all solutions, in this case in radians. So what's it in radians? And I'm going to add that, just so we know where it is. But we're going to do it the same way. Isolate, resolve, and solve. Here you have 3 equals 2 minus 2 sine of 3 theta. So we're going to start by isolating, subtracting the 2 on both sides. Now I have 1 is equal to negative 2 sine of 3 theta. I'm going to divide by the negative 2, which cancels here. So now I have negative 1/2 is equal to the sine of 3 theta. That's the isolate part. So put it over here. To resolve it, I just take the inverse sine of both sides. So I get inverse sine of negative 1/2 is equal to 3 theta. And at this point, I might want to evaluate that inverse sine of negative 1/2. Try to figure out exactly what it is. So I visualize. I go over to my unit circle. Sine is the vertical axis. Sine is the vertical part of the angle. So with cosine, I had the horizontal axis, and I went negative 1/2. With sine, I'm going to go along that vertical axis, negative 1/2. So down 1/2 from the center. So here's my center, down about 1/2. Those are going to be my angles. So like the angles that connect there. One there. One there. And all that really does is allow me to take this algebraic expression and sort of visualize what it means on the unit circle. For me, at least, that is a gigantic help for solving these. Now I can see I need one angle in the third quadrant, and I need one angle in the fourth quadrant. Okay. And I know those angles from the unit circle, but we'll do it on the calculator this time. So I'm going to do the inverse sine. Well, actually, let's just bring up the calculator. Oh, no. We'll do that next time. I'll get that back up and running. But, sorry. We'll do it with this calculator. So, I'm going to do mode radians, make sure it's in, and do the inverse sine of negative 0.5. And that gives me negative 0.5235. Let's see if we can, there it is. Okay. Inverse sine, negative 0.5, negative 1/2. And that gave me negative 0.5235. We'll go 2 decimal places. Okay. So that one, that particular angle is that one right there. This is the angle negative 0.52 radians. It's the only one. I know that there are 2 pi radians in a circle, 6.28. I know 180 degrees is pi radians, 3.14, So the only place that that negative 0.52 makes sense is at the fourth quadrant, just down a little bit. So right there. Okay. Plus or minus 2 pi. Okay. But my calculator didn't tell me this other one. So I've got to figure that out using a little bit of geometry, which is that I know that 180 plus that angle there, which is that negative 0.52, will work. So I do that. I go 180, well, not 180 radians, pi, so 3.14. Because again, I know that this is pi, and I know that this is equal to this angle. So I know this angle and this angle are equal. So if this angle is 0.52 radians, so is this one. So I'm going to do 3.14 plus 0.52. You notice that's all I did there. But the only way that I knew to do that, which is 3.66, by the way, radians. The only way I knew to do that was geometry, looking at that image and saying, well, how can I figure out this other angle that my calculator did not provide? I can use that geometry. So I did. Now I can break this down. I have negative 0.52 or 3.66 plus or minus 2 pi in times is equal to 3 theta. And I can see again, even though this side looks very complex, in order to solve for theta, all I really need to do is divide by 3. So I'm going to divide this side by 3. Divide both sides by 3, but that just cancels that, so it doesn't tell me theta. And so that's what I get over here. Theta is equal to, take my angles there, so negative 0.52 divided by 3 is negative 0.17. So that's that one. 3.66 divided by 3 is 1.22. Verify that, but 1.22. 1.22 radians. Plus or minus. And then the period also gets divided. 2 pi divided by 3, just 2 pi over 3. And that's what my answer would look like there. And again, it's just isolate the trig function, resolve it using the inverse, either by your calculator or by the unit circle. If you're using your calculator, you have to be careful. It's going to tell you one of the answers. It's not going to tell you the second one. You have to figure that out from the unit circle. That's why we covered the unit circle first, because it is intrinsic to how trigonometric functions behave. So your calculator says, look, I'll find this first one for you, but you're on your own for the other one. So I recommend making sure that when you're solving these, draw that picture out to get that second solution. Now, let's look at some of the ones that they have on Khan Academy. So let's get rid of this. Oh, there. Okay. So here, it's 7 cosine of 5x plus 9 equals 12, and it wants the answer in degrees. Okay. So we're going to work that. So I'm going to rewrite this so we can see it. So it's 7 cosine of 5x plus 9 is equal to 12. I'm going to start by isolating. So I need to subtract the 9, divide by 7. So we're going to isolate first. 12 minus 9 is 3, divided by 7 is 3 over 7. We'll just do it that way. So we end up with cosine of 5x is equal to 3 over 7. Three over 7 is not something I recognize from the unit circle, so I'm not going to worry about that, but I am. And that it's not pi over 6, pi over 4, pi over 3. I am still going to use the unit circle, but it's not one that I should know or have memorized. So I take the inverse cosine of both sides. That ends up giving me 5x is equal to the inverse cosine of 3 over 7. This is where I draw the unit circle to kind of imagine what that 3 over 7 would look like. So I'll do that. Here's my unit circle. I know that cosine is the horizontal leg of the triangle. So I know I'm looking for either a right or left distance. Inverse cosine of 3 over 7. So from the center of my terribly lopsided circle, we're going to go 3/7 in the positive direction. So it's just like graphing. 3/7 isn't very big. And then, so my angles for x would be this and this angle down here. One in the first quadrant, one in the fourth quadrant. So now I do that on my calculator. The inverse cosine, we got to go back to degree mode. So we're going to make sure we're in the right mode. So we're getting degrees and not radians. Whatever that is what your calculator should be in. So we need to be in degrees. Inverse cosine of 3 over 7 is 64.62. So I know that's that first one. This is 64.62 degrees. That did not tell me that one. Again, look at your calculator. It's only giving you that first, where is it? There it is. Up there it is. 64.62 degrees. It didn't tell me the second one. I know there's a second one only because I am familiar with the unit circle and I sketched the system out. So I look, if that's 64.62, that's this angle. That must be equal to this angle. So that's 360 minus that will give me the measure of that other angle solution. So 360 minus 64.62 is 295.38. Plus or minus 360. So now we have 5x is equal to 64.62 or 295.38 plus or minus 360 degrees in times, which for some reason they put the in front. Doesn't matter. It's multiplication. But we haven't solved for x yet. We haven't actually solved for x. We've solved for 5x. We need to divide by 5 as our last step when we're actually solving the equation. So we're going to divide both sides by 5. And then all we have to do then is match our answers up. So 64.62 divided by 5. 64.62 divided by 5. It's 12.92. $295.38 divided by 5 is 59.076 or 59.08. Because it's division, we're not adding or subtracting something to the angles. We're dividing them into fifths. The period also gets divided. So 360 divided by 5 is 72. Okay. So now I got to match that up. I need to find 1292 plus or minus 72, 59.08 plus or minus 72. And any other combination, so that's got a period of 360. That's not it. That's got a period of 180. I can get rid of all of the answers that have a period that does not match that 72. That leaves me with the 12.92 plus or minus 72 in. So that one should work. And this negative 1292 point plus or minus in. Well, let's see, because we have that plus or minus. These might not be the only ones. Let's see what happens if we move through that system. It's negative, so I'm going to do the subtracting part. So 12.92 minus 72 is negative 59. That's not that one. Let's look what happens at the 59.08 though. 59.08 minus 72 is negative 12. So if I do the 59.08 minus the period, I get that negative 12.92. So we have to check all our possible answers because that also works. Notice here I eliminated based on the period. I knew right away that these didn't match. Okay. And then I checked the two that were remaining to make sure. It's possible that C was not a solution, but in this case D and C are both solutions. What's the next one look like? Just for curiosity. Okay, same idea. All right, guys. Hopefully that helps. I'll post a word problems video coming up. It's mostly isolate, resolve, and solve and paying attention to how they're describing it. So not too bad. And then I will post a test on this, multiple choice most likely, on Friday. A couple free responses, but mostly multiple choice. All right, guys. Good luck.